Okay, now we're going to talk about some types of reactions, 3 different types of reactions. The first is a combustion reaction, and we've already looked at this when we talked about global warming and climate change. So a combustion reaction is characterized by reaction with oxygen, and it'll form 1 or more oxygen-containing compounds. Another important feature of combustion reactions is that they emit heat. Why do you burn propane gas in your grill in your backyard? To make the backyard colder? No, to cook your hamburgers, right? You burn it because it gives off heat. So all combustion reactions are going to give off heat. For compounds containing carbon, hydrogen, and oxygen, it's also true for those just containing carbon and hydrogen, the products are always carbon dioxide and water. So that's something I do expect you to remember. Always carbon dioxide and water. Here's the example. We looked at this one before. Here we have methane reacting with oxygen to form carbon dioxide and water. We identify this as a combustion reaction because we've got something reacting with oxygen and the products have oxygen in them. So we should be able to write balanced chemical equations for the combustion of a compound that contains carbon, hydrogen, and possibly oxygen. And what we need to remember is the other reactant is oxygen, because you can't have anything burn without oxygen, and the products are CO2 and water. So we'll start here by just writing down the formula which they gave us. That's ethanol, by the way. Ethanol, the prefix eth means 2 carbons, so it's 2 carbons, and we recognize it as an alcohol because it has that OH group on it. And that's a liquid. So in writing a balanced chemical equation, first we have to get the skeleton, all the formulas. What's the other reactant? O2. And what's the state of that? A gas. And what are we going to form? Carbon dioxide and water. What will be the states of those? Gas. So carbon dioxide is pretty easy because there's carbon dioxide that you give off in your breath, right? You take oxygen in, carbon dioxide comes out. They're both gases, they're part of air, right? The H2O, though, usually H2O is a liquid. But is this going to be a cold or room temperature situation? No, we're burning something. It's going to get warm, if not hot. So the water that's produced is going to be in the gas state. When you heat a beaker over a Bunsen burner, or if you have a gas stove at home and you hold a pot with water in it over, you can see there's condensation that comes and develops on that colder object. The condensation is this water vapor that's being created during the combustion process, because when it hits a cooler surface, it will condense. Okay, so now we just need to balance this, and I'm just going to do this by inspection. We'll start with the beginning. So let's look at carbon. What do I need to do to balance the carbon? Yeah, I need to double this one over here. So I need 2 CO2s, because I've got 2 carbons here, and I only had 1. So if I have 2 CO2 molecules, that'll give me 2. And then hydrogen Need to be a little careful here because all the hydrogens aren't together. This is 5 hydrogens in 1, which is 6, right? And over here, the hydrogen is showing up in the water. And so I've got 2. I need to multiply by 3 to get 6 hydrogens. Everybody following that? Now this is where it gets a little messier. Oxygen. Everything has oxygen in it. So this is where we want to use that suggestion that we use the elemental oxygen to finish up. We could balance oxygen by messing around with these other things, but that would mess up what we already did. And we don't want to do that. So let's just look at what we've got. So from this guy over here, I've got 1 oxygen. And from this, I've got 2. Here on the other side, how many oxygens? 4 and 3. So I have a total of 7 on the right side. I need to get 7 on the left side. Well, I don't want to change this one. So, if you think in terms of algebra, basically I'm doing 1 plus 2x equals 7. What is x? Well, it's 3. What do I multiply this by so that when I add 1, I get 7? Well, that means I need 6 from here, multiplied by 3. Balanced chemical equation. Any questions? Look at the alkali metal reactions. Alkali metals react very vigorously with nonmetals. And we can look at how they react with halogens. So here in this equation, there are no elements M and X. We're using capital M to stand in for any one of the alkali metals, sodium, potassium, whatever. And the halogens we're abbreviating or representing with X. Could be fluorine, chlorine, bromine, iodine, any of those guys. So 2 of the alkali metal atoms will react with 1 molecule of the halogen element, and it'll create 2 molecules of a metal halide. We can look at sodium and chlorine as an example. So 2 sodium atoms react with 1 chlorine molecule to make sodium chloride. And this is a picture of what that reaction looks like. There's sparks and flames and lots of heat, right? Very vigorous reaction. Why is this have this formula MX? What kind of ion do the alkali metals form? What's the charge? The alkali metals have a charge of +1 when they become ions. And the halogens, chlorine, fluorine, bromine, what charge do they have? -1. So this one's +1, that one's -1. That's why the formula is MX. The reactivity actually increases going down group A. So, sodium is vigorous, potassium is more vigorous, right? It gets more violent. Alkali metals will react with water. Here we see them in beakers of water, but they will also just react with a little bit of water that is the humidity in the air. Alkali metals react with water to form dissolved alkali metal ion, the hydroxide ion, and hydrogen gas. So 2 metal ions and 2 water molecules are going to make, 2 metal atoms are going to make 2 metal ions, 2 hydroxide ions, and hydrogen gas. And these are also exothermic reactions. And they get more violent as you go down the group. So lithium going down, sodium, potassium. So this is like fizzing and reacting vigorously. This is actually, we're getting a little bit of flame here. And this is like shooting sparks all over the place. And what's happening here is we're generating hydrogen gas, which is flammable, and heat. And so that's igniting the hydrogen gas. Any questions? Let's look at halogen reactions. This is a picture showing the elements chlorine, iodine, and bromine. So chlorine is kind of a yellowish green gas at room temperature. Bromine is a liquid at room temperature. We do see it also in the gas state here because when you have a liquid, some of it's going to evaporate. And then here we have iodine. And iodine is a solid, and iodine is kind of cool because you can get it to sublime. So it'll go from a solid to a gas without melting, and the gas is this really pretty purple color. Of course, you don't want to be breathing that, right? No. So lots of metals will react with the halogens. We just saw how the alkali metals do it, but other metals will do this as well. So here's 2 metal atoms plus some number of halogen molecules. That's going to give us 2 of this with this formula. The reason we're using an N here is N is going to represent the charge on the ion. So it might not be +1, might be +2 or +3. And so that will affect the kind of product that's formed. Here we've got hydrogen reacting with a halogen. And what these do, when halogens react with hydrogen, they're going to form a covalent compound. And these are in the gas state. But what does that remind you of? Acid, right? We said an acid was something that when you dissolve it in water, it produces ions. So if we take this and dissolve it in water, it ionizes, right? But as a gas, it's not ionized. And then we can also get halogens reacting with other halogens. We're getting all kinds of funny combinations. Not funny, haha, funny, strange. So let's do these examples here. So A and C are ones that I could ask you on an exam. And they look kind of scary, but I'm hoping to show you that they're not. So we're supposed to write balanced chemical equations for the reaction between aluminum metal and chlorine gas. Well, what's the formula for aluminum metal? Al. What's it? It's a solid. And chlorine gas, what's the formula? Cl2. And it's a gas. They told us that even. It's Cl2 because it's one of the diatomic 7. That could be a new superhero group. The diatomic 7. I'm not going to go. I'm not going to do it. I'm not going to do it. Not going to do it. So these are going to react and form a compound. Okay? So what's the formula for the compound formed between aluminum and chlorine? We asked questions like this in Chapter 3. We were learning about nomenclature. Aluminum is a metal. Chlorine is a nonmetal. So this is going to be an ionic compound. What ions do aluminum and chloride form? Aluminum makes +3, and chlorine becomes chloride with a -1 charge. We can write the formula for this because we know the charges. So what should the formula be? AlCl3. Now what's the state of that? We will learn that ionic compounds are held together very, very strongly, and so they have high melting points. So if you see an ionic compound like salt, table salt, sodium chloride, is solid at room temperature, right? You can assume that any ionic compound is a solid at room temperature. And then we need to balance this. Well, aluminum's fine. There's one of each. I've got 2 chlorines here, and I've got 3 chlorines there. What do I do? This is the odd-even thing. I need 3, but they only come in pairs. So if I double this one and double that one, the aluminum is still balanced. And now I've changed my odd number into an even number. So 2 times 3 is 6 chlorines. I go over here, and I can tell I'm going to need 3. Okay? I'm going to do the last one next. The reaction between gaseous hydrogen and liquid bromine. I remember as a student predicting and writing chemical equations. That was like kind of scary stuff, because it's like, wait, was I supposed to memorize that? How am I supposed to know how to do that? Well, the first thing is just write down the formulas for the reactants. They have to tell you what the reactants are, right, so that you can write the correct equation. Gaseous hydrogen, how do I write that down? H2 gas. Hydrogen is a diatomic element. Writing these equations is one of the big places where it's important to remember which are the diatomic ones. And plus liquid bromine. What's the formula for bromine? Br2. It's a liquid because they say it is. Horses need oats for clear brown eyes. So there we have the horse and we have the brown. Well, how do we predict what this is going to make? There's not a lot of options. It has to be hydrogen and bromine together, right? Got to be hydrogen in there and bromine in there. How many of each? Well, that hydrogen should make you think this might be an acid, right? If it's an acid, when it dissolves in water, it forms ions. What ion does hydrogen form? +1. Just like the alkali metals, it's pretending to be an alkali metal over there. And what ion does bromine form? -1. So by identifying the charges that it would have if it was dissolved in water, we can write the formula for it, HBr. I would not expect you to know that this is a gas. Don't expect you to know that. How do I balance this? I need a 2 in front of HBr. I've got 2 hydrogens and 2 bromines, so I'm going to make 2 of the product. So if you have to predict products, write down the formulas for the reactants, and then think about what sort of a compound could be formed from those 2 elements. most molecular compounds will not show up as one of the possibilities because you have no way of predicting what's going to happen. It's usually going to be an ionic compound or an acid. The one you do memorize is something reacting with oxygen that has carbon, hydrogen, oxygen in it, CO2, and water. Okay, let's do this one. No, I would not ask you to do this on an exam. Reaction between lithium metal. Okay, so lithium is Li. It's a solid. And liquid water. Well, the metal is going to have to combine with some nonmetals, right? Hydrogen and oxygen. What kind of a compound is that going to be? Ionic, right? So what kind of an ion does lithium make? Plus one. So Li plus. And then we might not be exactly sure of what to do with the water. Because water doesn't have a charge. How do we make that into an ion? It's just kind of a mess. Let's look back at this slide. So the alkali metals react with water to form a dissolved alkali ion, a hydroxide ion, and hydrogen gas. So the other two products are hydrogen gas and hydroxide. So I'm going to get that ion. That's going to be dissolved in water. And from looking at what the book said, I'm going to get hydroxide ion and water. Water's the one compound that's never described as aqueous because water dissolved in water is a bit redundant. How do we balance this? I did something wrong. I've got a product here that's the same as the reactant. Yeah. Okay, so what's the other product? It's hydrogen, H2 gas. I'm like, wait a minute, there's nothing to catch fire. That's no fun. Okay, how do I balance this? Lithium's okay. Oxygen is okay. But the hydrogens aren't. Over here, I've got 3 hydrogens, and over here I have 2. Well, yeah, let's try 2H2O. So that's going to give me 4 hydrogens, which is closer to 3 hydrogens, but it also changed the oxygen. So let's fix oxygen before we finish the hydrogen. Now I've got 2 oxygens. Over here now I only have 1. So I'll put a 2 in front of that to rebalance the oxygens. And now I can look at the hydrogens. There's 2 hydrogens and 2 hydrogens, which is 4, and ta-da, there's 4 over there. Any questions? Yes.